This is the Mark I HC-SR04 I2C Octopus board using the library from github.com/arielnh56/sonar I2C. This allows you to put 8 HC-SR04 ultrasonic sensors on your Arduino using the I2C bus and 1 interrupt pin. So you can put more than one of these on if you use more than 1 interrupt pin, or you can in fact multiplex even more if you really need that many sonars on your device. 8's usually enough. I2C bus here is the pinout used by the Grove people. Then we have a non-connected pin, and then we have a pin here that goes back to your hardware interrupt pin on your Arduino. Here we have the ability to add pull-up resistors for the I2C bus if you need to put them on this end of the bus. Usually you can leave those empty. It really depends on the electrical characteristics of your circuit. The individual outputs here have the same pinout, your voltage there, your trigger, echo, ground. The square pin is the ground all the way around, so you follow it around anti-clockwise. This is 0. 1, 2, 3, 4, 5, 6, 7 in an anti-clockwise direction. Unfortunately, I missed one of the silkscreen layers during the build and missed out that labeling, so refer to the documentation for which port is which. The addressing on this is hex 3D. Again, the labeling for the address jumpers is missing. So A0 is to the end of the board, A1 is in the middle, and A2. And they are, as I say, they ship as 5 hex 3D, which is unlikely to collide with another device, so you probably don't have to mess with that. The way the library works is you can only hit your sensor roughly every 50 milliseconds so that the existing pulse echoes and so forth can die down, so you avoid interference. So this keeps track, the library keeps track of, is it time to send another pulse? It sends it to the next one in sequence through this expander chip, sends out the pulse, sets a hardware interrupt routine to wait for the echo to come back, and then program can go off and do its own thing. When the echo comes back in, it gets multiplexed through this 8-way NAND gate and sent back through the hardware interrupt pin to trigger the hardware interrupt routine, which then remembers how long it took, and then it saves it for when your program wants to look and see how far things are away. So that part of the routine just reads that number and translates it into millimeters or centimeters or inches or whatever. This ships with standard headers, so you can plug those in right away. If you want to use locking headers, there's space for those. And it's got the 3mm mounting holes, so you can put them on standard you know, those little brass things. Anyway, that's the octosonar.